When you look up at Saturn, do you ever wonder what it would look like if our planet had rings of its own? Well, scientists may have just answered that question thanks to an ancient crater in Greenland. Let's take a look. Located about 300 miles from the closest point in Antarctica, this giant crater is estimated to be 56 million years old. That's about the same age as the Chicxulub crater in Mexico, which was created by the asteroid that wiped out the dinosaurs. But the manto structure is much larger than Chicxulub. It's about twice as wide and 10 times deeper. Our story begins in southwest Greenland, where towering cliffs line a large crater named the Manto crater structure. But before that, it may have looked something like the rings of Saturn. Not only did the researchers confirm the existence of the ring, they also determined its exact composition. According to geologist and lead study author T. Sean Collins, the ring was made of pulverized rock and dust mixed with clay minerals. These materials were likely carried aloft by powerful winds and deposited in layers on top of the ice sheet that covered northern Greenland at the time. Scientists think both craters were formed by asteroids about 8 to 10 kilometers or 5 to 6 miles across. And it answers a question that scientists have been wondering about for a long time. Impact craters are usually associated with mass extinctions, but sometimes they can kickstart evolutionary events, including the formation of life. Or check out this video on the mysterious death of a star. Thanks for watching, and see you next time. In fact, some scientists speculate that the asteroid impact that formed the manto structure triggered the initial diversification of mammals. Mammals had been around since the late Triassic period, but at that time they were small proto-wombats, mostly insect eaters. After the asteroid impact, however, new ecological opportunities arose, such as a dramatic increase in plant diversity. In a matter of a few million years, mammals went from tiny proto-wombats to much larger animals. Some of these early mammals continue to thrive today, such as bats, whales, and primates. So it seems that asteroids aren't always bad news. The thing is, we don't have any records of either event, meaning they left no mark in the geological record. In order to learn more about how this crater formed, researchers used a variety of tools, including ground-based radar, a technique called cosmogenic nuclide analysis, and computer models. And that's when things got really interesting. They found that after the asteroid slammed into the Earth, it left behind not just a crater, but also a ring. See, during the impact, huge amounts of sediment and rock were thrown into the air. Most of it fell back down around the crater, but some of it formed a ring that extended 200 kilometers from the center of the impact. They discovered that the asteroid hit the Earth at an angle of about 45 degrees. It then exploded with the force of 10 trillion tons of TNT, about 400 times the energy released by the atomic bomb dropped on Hiroshima. This created a huge cavity in the Earth that eventually filled with water, forming a lake. But over time, glaciers carved the lake away, leaving behind a bowl-shaped crater. And that includes the one in Greenland. When it originally formed, the impact would have been catastrophic. It would have been a huge explosion, a tsunami, and a fireball, reaching up 30 kilometers into the atmosphere. But over the eons, erosion has worn it down. Today, the crater is pretty much all that remains of the asteroid impact. The reason it's important is because scientists can use it to better understand similar impacts that happened to Earth in the past and will happen in the future. Using computer modeling, scientists were able to reconstruct the Lake S basin and the surrounding area, as it would have looked millions of years ago. It's been eroded away by glaciers. But there was more to discover. Today, that ring doesn't exist anymore. This discovery suggests that asteroid impacts could have played a major role in shaping the early Earth. The next time one slams into our planet, I just hope it leaves behind a nice ring. If you enjoyed this video, go watch this one about a river of magma. Did you know that our planet once looked like a huge Christmas tree? How about that? Our Earth had rings? But where are they now?